Solutions in linear equations. We're going to use this more as a review, okay? In class, I'll be pausing as needed, but for the video, it's just going to go. Sometimes they're going to give us a graph like this right here, and they're going to go, hey, is this a solution? Or they'll say, is negative 2, 3 a solution? They won't even give you the dot, and you'll have to go put the dot. Well, if that dot is on the line, yes, it's a solution. If they give you a ordered pair, the dot that's not on the line, then no, it's not a solution. It's that simple. Now, to explain why this is the case, let's take a look at it. This same line right here is represented by the equation y equals x plus 5. If I asked you to graph this equation, you would be graphing this blue line because the y-intercept is positive 5 and the slope is plus 1. So we go up 1 and over, up 1 and over. Okay? So, the red dot's location is found at negative 1, 4. How do we know that? Because it's right over negative 1 on the x-axis. And what are we going to do with this ordered pair, this red dot's ordered pair, the location of it? We're going to take its x and y values, the negative 1 and 4, and we're going to put it into this equation of the blue line. So the x becomes a negative 1. The 4 is indeed the second part of that red dot's ordered pair because it's sitting right here at 4 on the y-axis. And we're going to make the y a 4. Why? Because the 4 is the y coordinate, so that 4 is going to become a y. And remember, a solution to an equation is if you can plug in values for the variables and it makes both sides of the equation true, then it's true, it works. And we said that this red dot is a solution. So we're saying that if we take the numbers for the x and y from this red dot and plug it into the equation, which is the blue line, it will make them true. So does 4 equal negative 1 plus 5? Well, negative 1 plus 5 is 4, so yes, it makes it true. So that's why, if the dot's on the line, we'd say it's a solution. Let's take a look at the dot if it's not on the line. That red dot is sitting there right over the 2 on the x-axis, and it's right at 4 on the y-axis. And remember, we said that a solution is if we take the values and plug it in for the variables in the equation. If it makes it true, then both sides are equal to each other. If we take this 2, 3 and we plug it in here and they're equal to each other, we'd have to say this is a solution. But we don't because we said, hey, this red dot's not on the blue line, so it's not a solution. So what we're expecting is that when we plug this in, these two sides will not equal each other. Let's go see if that's true, if they don't equal each other. The 2 is an x, so make the x a 2. The 3 is a y, so make the 3 a y. And 3 does not equal 2 plus 5. 2 plus 5 is 7. So, sorry, this ordered pair right here, this red dot, is not a solution to this blue line. It's that easy, okay? The ordered pair has to make it true, and this one does not make it true. So, how many solutions can a linear equation have? Well, I can see that this red dot would be true. But then I also see that there could be other dots on there. Let's make a table here and just record all the possible solutions to this line that we see here. The red dot would be negative 5, 0. This green dot would be negative 4, 1. And you can see all these other dots with the solutions on there. But wait, you see this arrow here? It goes on forever in this direction. So we could get a whole list of extra solutions on here. Some extra ordered pairs that would make this equation true if we kept going. And the same is happening down here too. So there is a never-ending supply of linear equations because that line goes on forever. And that makes it interesting. And sometimes instead of saying is it a solution, they expect you to come up with the solutions. So let's take a look at finding 3 solutions for y equals negative x minus 3. I expect you to be able to know how to graph this line. So here it is graphed. There's the blue line, okay? Negative 3 is the y-axis. Negative 1 is your slope. So how do we find 3 solutions? We go find some ordered pairs, and this one has a lot to choose from. Every single dot is a solution. So how many do they want? They want 3. How do we show it? Just make an XY table and go steal the values. This dot right here would be negative 3, 0. This dot right here would be 0, negative 3. And this dot right here is 2, negative 5. Why did I choose those 3? I don't know. I just chose 3 different dots, and that's all that matters. You might have chosen different dots on here, like this one, -5, 2. That is just as good. Okay, so just find 3 easy dots for you, record the ordered pairs in your table, and you're done finding the solutions. If we could stop right here, it'd be great, but not all lines can be easily graphed. So we need to look at how to come up with solutions without graphing this equation. What if they give you the equation and say, give me 3 solutions, but for some reason you can't graph it? Okay, well, we'll still need to get the XY table. So let's take a look at how we can find solutions to this very equation without graphing it. You take the equation, you write it down on a piece of scratch paper, or on the paper if you want to see the work, and you literally just plug in a fake number for x. Just come up with a random number. It does not matter. You choose, okay? If you're asking Mr. Tate, why did you make this x? What I'm about to make it is because I just randomly chose it. Now let's look at this equation. Guys, I've told you over and over again, what should we put in front of this x here if you just see a negative x? If you don't see a number in front of the x, put a 1 there, okay? Now, let's just make the x a 0, and on our table, I'm going to write 0 right there, okay? Take the time to record that, so there's 0 for x. Now, to get the y right here for our first ordered pair, we're going to go solve this equation for the y that's left over. So -1 times 0 is 0, right? And 0 minus 3 is -3. So y equals -3. Write that down right in your table right here. We have to come in and do it again. Remember to keep that 1 in front of the x there when it's this type of scenario, okay? Plug in a different number. We've already used 0, so you can choose any number you want except 0 because we've already used that. How about 2? So we'll write down 2 in our table. -1 times 2 is -2. -2 minus 3 is -5. So write that down right there, and we've got our second solution. Next off, last one, plug in another number for x. Don't use 0. Don't use 2. Don't forget to put the 1 in front of this x here, okay? How about -3? So write down -3 in there. -1 times -3 is +3, and +3 minus 3 is 0. So y equals 0. There we have it. We've come up with 3 solutions. Last thing I want to go over real quick. What happens when you have a standard form equation? What if it's not like that slope-intercept? What if it looks like this? Same thing. Just go find a number for x, okay? Keep it small. I love putting in 0 for x. So let's make the first one 0 for x. So write that down on your table there. 3 times 0 is 0. Minus 0 from both sides. 4y comes down. 12 comes down. Divide by 4. Divide by 4. Y equals 3. Write that in your table. Go choose a different letter for x. Hey, no problem. It's not always going to be easy for the nice round number for the y, though. Sometimes you'll get fractions, and I'll show you that right now. Let's plug in 3 for the x. So write that down on your table. 3 is for x. 3 times 3 is 9. We'll need to minus 9 on both sides. The 4y comes down. 12 minus 9 is 3. Divide by 4. Divide by 4. Sorry, you didn't get a whole number for y, but you did get 3/4, and that's what we can put on the table. Yeah, you could know that is 0.75. You could write that down, but fractions is normally better because if you ever ran across a repeating decimal, that gets really nasty, and you'd have to round, and that takes away the truthfulness of your answer because then you're rounding. Fractions, though, are precise, so I would just keep a fraction simplified as your final answer there. Now, last one, I wanted to show you this little trick. You don't always have to plug in x. You could plug in something for y and then go get your x. So let's plug in 0 for y. Just remember, write it under the y column because we've already done x is 0, but this time we're going to plug in a 0 for the y. So this y became 0. Now we just go solve for this x here, okay? 4 times 0 is 0. Minus 0 on both sides. If it was a number other than 0, you'd have to do something to get rid of it. It's a two-step equation, right? Drop the 3x. 12 minus 0 is 12. Divide by 3. Divide by 3. And we have it x equals 4. And that's how you can do it without graphing. Good luck.